Okay, so welcome to this video. In this video, we're going to be examining this problem statement. So it says, a local community college is exploring the relationship between mathematics anxiety and final exam scores in a beginning math course. And they've asked your firm to examine data and eventually to determine if mathematics anxiety is reliably correlated with the final mathematics score. So you're part of the data science team. As a fresher, the data has been cleaned for you, and the team has assigned you to conduct the EDA, exploratory data analysis. So if you have to answer the following questions, okay? And the first question is, which gender has the higher final scores? So the second question is, which gender has the highest or higher anxiety score? Then we ask which instructor. So we're going by gender, looking at final score, anxiety score. We're going by instructor, looking at anxiety score. And then we're going to look at anxiety score by instructor for gender. We want to know if there's any outliers for anxiety or final score. And then we want to know what are the mean, final, and anxiety scores for each instructor in general. And also by gender, for each instructor by gender. And then we want to know if there's any skewness in our data for each of our two variables. And using skew, which instructors' final or anxiety scores are skewed. And then finally, which one do we think is better for female with high anxiety, which is better for male with high anxiety? Okay, so for a lot of these, we're going to be doing like just your typical commands. So we might start, of course, by importing our library. So we're going to import. In this case, I'm just going to use pandas. Yeah. So I'm going to import pandas to create a data frame. Okay, and then to do that, I just say import pandas as PD. And that's going to allow me to use PD instead of the whole word pandas. So just a little bit about our variables. You can see that we've got, well, let me grab the data and then we can check it out from there. So the next thing I want to do is go ahead and grab my data, and it is stored over on the internet. So let me grab this URL first. Actually, let me grab this URL. Yeah. Okay. So here we're going to go ahead and grab it. So I just created like this df equals pd dot, sorry, read underscore CSV. And then I need some quotes, single or double quotes are fine. And then I just paste the location of the CSV. Okay, now I've got it stored here, and we can go ahead and start by just looking at the shape. So the data in this case, it should be 103 rows and 4 columns. So that's what that's going to mean there. Next, we want to look at just take a look at it. You can see I've got instructor, final, anxiety, and gender. Okay, and then we can make sure to check the data types and make sure we don't have any missing values. So we want our categorical variables like instructor and gender. We want those to be either objects or categories. You can see that they are. And then we want our final and anxiety scores, which are continuous variables, to be stored in either integers or floats, something numerical, and we can see that they are. So at this point, it's definitely possible if you're dealing with a large data set, especially like the housing predictions data set, if you've ever used that, you'll have a lot of your variables that are categorical stored as integers because they are, the integers are representing that category, some particular category. And so at this point, you would want to go ahead and see if you can change any misclassifications, or you might want to do that later on. Basically, it's up to you, just how you want to do it, right? Okay, so then our next thing is, we can also see we don't have any null values, so you could go ahead and check for that. Like this. And this will tell us by category if we have any null values or not. Okay, so then now we can come to our descriptive statistics. So I'm going to look at df.describe here. And this is going to bring me back only my continuous variables. And so basically, what are we going to look for here? Well, I have the final and anxiety score, and I happen to know that these cannot be less than 0 or more than 100. And so I'm going to look at my min here, and I see one that's like 0.05, which might be a mistake or might not. Not sure about that. And then we have for our max values, nothing is over 100. So at this point, if I had numbers here that were less than 0, or if I had numbers here that were greater than 100, I would go ahead and remove those because they would be impossible. It would be some kind of a mistake, right? So the next thing I want to do then, so at this point, I might want to go ahead and check for duplicates. And we can do that like this. So I'm going to say df dot duplicated. And then here, I'm going to do like this, put it in here. And I can see that there's one duplicate, right? And so I could go ahead and just drop this duplicate, but that's not really part of your problem statement. So at this point, you don't need to do that. But if you want to, you could. So if you use df.drop and then just paste this in here. And now make sure you say in place equals true. Okay, and now if we do this command here, we shouldn't get anything. Oops, there's a mistake. Oh yeah, so we also need to specify the axis. Okay, so for the axis, the rows are going to be axis 0 and the columns will be axis 1. Oh, I didn't want axis 1. Why did I do that? Uh-oh. I better check it now to see if I destroyed something. Yeah, I did. I got rid of all of the columns that were in that. Okay. Okay, so that's not a big deal. We can just first I'll change this to the correct one, and then we'll go back up here. So this is a good thing is you can always restart your kernel. And we're just going to run everything again. And when I get back down here, it should be fine. Okay, so it stopped here. Oh, what is it now? It says it didn't find it in the axis. Really? Okay, let me just change one thing. I'll just change it to 53 because that's the index of this. Okay, maybe that's going to be easier. Now everything's good, but I have one less row. And now if I run this command, it should be gone. Yeah, now I got an empty data frame. Okay, so I got rid of that. Like I said, it wasn't part of the problem statement, but you know, why not take the opportunity? So the next thing we want to do is look at which genders had the higher final score or the higher anxiety score. And there's lots of different ways that we can do this. And so one way we can do it is just look at use grouped by. So I'm going to say group gender, and then I'm going to say df.group by. And then in here, I'm going to put my gender. Okay, and then I'm going to take this and run this command where I'm going to group it grouped like this. And then inside, I'm going to pass the list of these two continuous variables. All right, and there's a couple of ways we could do this. We could either look at the mean group. group gender. We could look at the mean. And so let's go ahead and do that. Okay, and then we can also look at the median just to see, if there's any change. Depending on the skewness, there could be. Okay, so you can see here that, oops, I didn't print it yet. So for the okay, so the question we want to answer is which gender has higher final score and higher anxiety score? So now higher is kind of like, do we mean max higher? Do we mean by median like this? So if we're looking only by the mean values, then you can see that for anxiety, the female and male are very close together, but actually the males have the higher anxiety score for going by the mean value and also going by the median value. Okay, and then if you look at the final exam score, you can see that the males have a higher anxiety. I'm sorry, for the final exam score, the males have a higher final exam score mean, and they also have a higher median exam score. Okay, so so that's if we're going by like, which one is the higher mean or the higher median. If we're interested in like the maximum value, then we could also do like this. We could subset this. So let's say I'll subset this. Actually, I'll just go like this. Yeah, we're going to subset it by gender. First we'll say by female. And then, so I'm going to say DF female equals this. And then what I want to do basically is try to find the max of this. So this is creating a data frame. Oh, wait a minute. Hold on a second. So first, let's just get the data frame. What is this? Oh, okay. One last thing. Okay, now let's get it here. What? This doesn't make sense. Oh, because there's no F's. Okay. Alrighty then. Now we try it. All right, great. Now we can just get the max of that and compare it with one for the female, or for the male rather. So the males will look like this. And let me just change this over here. And so let's see, what do we get? So we get that as far as max scores go, both male and female have 100 score level, and the male has the maximum anxiety score. Okay, so those 3 different ways of looking at the same result. So overall, it seems, pretty clear that the higher anxiety scores will be the males and the lower anxiety scores would be the females. Slightly though, not much, so and then here we could also do like take our subsets here and first of all, I have to remove this. You could also just take a look at the descriptive statistics per category here. Well, actually, let me just get rid of this. Okay. And also for the male, we can do this. But what we're really interested in is if they're more high values than low values, right, for male or female. So the way we can do that is just to go. So we can take a look. Is there a difference between the mean and the median? We've already seen that actually. So for the females, the median is slightly higher than the mean. Actually, it's kind of pretty higher. And for the males, the mean and the also we have the same situations. So if we look at our skewness, what will we get? We see the anxiety is left skewed, which means that there are more high values than low values, right? And we can do the same thing here for males and see what we get as far as the skewness goes. Okay, so this is a little bit less skewed. So it does seem like, well, maybe the females have more higher anxiety scores. And when it comes to final anxiety scores, maybe it's less skewed. Okay, so now let's go on to the next question. Which instructor has the highest anxiety scores, and then which one has the highest anxiety scores for each gender? So to examine this, we can also do basically a grouped by here, where we're going to, so highest anxiety score for gender. Yeah, so for this, we just do one, basically try to answer it in one line of code using group by again. So I'm going to say, create my new group, instructor equals df.group by, and then here, we get instructor, and then here we're going to get gender, and then let's get the results. Grouped, and then I'll get my final, pass in my final, and then pass in my anxiety score. All right, now let's see what we're going to do. Let's just get dot describe first and see what we get. Well, let's just do like this first. Yeah. Oh, I did that again, didn't I? Okay, so we've got it, the object. Let's first try this dot describe. And this, what does this do? It's giving us all of the descriptive statistics per instructor, and then per each gender here. So instructor A, male, female, and we can also see the count. We can see the mean. We can see the median here. Okay, so for instructor A, you can see that the median is higher for males. Also, the mean is higher for males. Spread is smaller for males than for females. And that's for the final score. If we go over here to anxiety, which one is which? Okay, so females are the top one. So here the anxiety score for females is higher. And then over here, look, this is pretty interesting. We have the same median value as far as anxiety goes for males and females. Okay, so this is, I mean, this is a good chart. It's a little difficult to make sense of. So why don't we, instead of looking like this, we can just change it to the mean first. So we're just going to be looking at the different measures of the center of the data, right? And so here I've got only the mean, and you can see precisely the mean scores, you know. So what are we looking at here? Let's just take a moment to examine it. So for the final score for instructor A, we've got 47. For females, 53 for instructor B, 62 for instructor C, 75.7 for instructor D, right? Okay, so you can see basically it's decreasing in this direction. Instructor D seems to be the best for females and for males, actually. And also notice that instructor D's anxiety scores are the lowest anxiety scores. So if you have to take this class, you probably might want to take instructor D, because not only are his final scores higher than every other instructor, also the anxiety is lower. Or instructor D, I said his because I'm male centric, because of that. It could be a female, obviously. So yeah, we don't know the gender of the instructor, by the way, and that might be another good variable that we could use. So then looking here, it basically, it seems like from instructor A, it just goes up. The anxiety level is the highest for males for instructor A. The anxiety level is the highest for females for instructor A. For all of them, yeah, basically it's just like a decreasing trend here from A to D. All right, so which instructor has so what is our actual question here? It says which instructor has the highest anxiety scores. So that's, it's kind of a vague question because I'm not saying mean, median, or maximum. So, and this is the kind of question you might get, right? You might get a vague question, and so it's up to you to interpret how to answer that. So from what I could see, it must definitely be instructor A, and which instructor has highest anxiety score for each gender. Also instructor A was pretty much the worst. So, well, I say worst, I mean the highest final and anxiety scores. And here's another thing that you might have noticed, and how easy it is to get sort of led astray if you're not careful. If we look at Describe, and also, to really be able to determine if there's any significant difference between these instructors, we would have to do an ANOVA test, some kind of a test to, statistical test to determine if there is a statistically significant difference between the means and medians of these instructors, right? So in a business setting, I noticed that sometimes that's not done, and the EDA there's too much, power given to the EDA like this. You have to do more in order to validate your response, right? So right now we're just getting an idea, and what I want to tell you is that sometimes it's counterintuitive. When we run the actual test, we might find something different, like there's no statistically significant difference. Even though we're looking at these scores, we see one is higher than the other. Okay, so here, looking at this grouping, we can see that if we look at the different counts, so let me see. Let me actually, let me do like this. Just a moment. And I'll show you what I want to do. So what I'm getting to basically is that not all the instructors have the same amount of students, basically. And if I take a look at, so let me just make it more simple. If I take a look at a frequency table, like this, and I want to pass in instructor and gender. So if I take a look at this frequency table, what I'm going to find is that if I add these together, what am I going to get? This instructor has 33 students. So the instructor with the lowest scores, I'm sorry, the highest anxiety score and the lowest final score has the most students, actually same as B. But looking at instructor D, who happens to have the lowest anxiety score and highest final exam score by, and when I say that, I mean according to the median and the mean values, by the measures of the center we're using. But he also has half the students. He or she also has half the students. And so it could be the case that if instructor D had the other half of the class, maybe the numbers would change. Yeah. So so that's something to think about as well. Okay, so it's so easy to look at this and overly simplify it. Okay, so and that's but as in general in this data, it's definitely the case that that right now, from according to this data, what are the mean final and anxiety scores? So I think we checked that one out. So right now, definitely instructor A has the highest anxiety score for each gender in general. And instructor D is so I would say instructor D is the answer to 10 and 11. So the only thing left to do is, but again, this is what it seems to be like, right? And then suppose we go on further and do an ANOVA across these 4 instructors and across the anxiety and final score. We may or may not get a result that says the difference is statistically significant. Okay, so right now we have a general idea informed by our initial analysis, and also you might get the feeling like we're missing something, and the thing we're missing really in this set of questions is the visualization, which can also help out. But again, the visualization can help, but it can also sort of lead you astray if you're not careful, right? So you're like, well, what are we actually finding out? No, that's not what I wanted to do. So now let's go back here and let's answer the last couple of questions. These ones. So they want to know if there's any outliers. And here. So I'm just going to move the questions down here so they're easy to see. All right, so I think I've answered this question, right? We looked at the mean scores, didn't we, here? So if I just change this to mean, then we got this, and I could also change it to median. So which mean final scores for instructor in general, can get those results here. And I also broke this down. So actually, this is really only by gender. So I guess I just wanted to first get the instructors only. So we can do that we can get the instructors only. We could just remove this variable and then run it again. Okay, so this gives us the instructors in general, which is going to be like the same idea. We've got highest final score is instructor D, lowest anxiety is instructor D. And then it just seems to follow a trend here, and instructor B. But then again, remember, instructor D has the least students. So, so if we want to, okay, so that's the answer to this question. You just remove the gender from that code if you're coding along here, and then add it back. So now we want to know, using the skew, our final and anxiety skewed. Okay, so we can do that. We can just do like this. Okay, now this is by instructor. If we're only interested in general, we can just do like this. And this is going to give us the skewness values. So for the final exam is not skewed really. So let me I think I've make sure I always forget if it's between 0.5 and or 0.05. Okay, yeah. So basically the rule of thumb is that if the distribution is, well, let me say it like this. If the skewness value, how about that? If the skewness value, which is what we just have generated here, is between negative 0.5 and 0.5, then we'd say the distribution is roughly symmetric. That's the basic idea. Roughly symmetric. So let me go back and put an H right there. And if it's greater than that, then the skewness basically goes up. So if it's between -1 and -0.5, or between 0.5 and 1, then it's sort of like moderately skewed. But if it's bigger than 1 or less than -1, it's definitely skewed, highly skewed. Okay, so the anxiety is highly skewed, and it's highly left skewed. Left skewed means that we have more high values than low values. Okay. But our final exam score is approximately symmetrical, so roughly normal. Basically, it's what we call a normal distribution. All right, so let's go to the next question here. It says, did we do the outlier question? Oh, we didn't do the outliers. So let's check for outliers, and then we'll wrap this up here. So to check for the outliers, there's just a couple of lines of code we can write. And basically we need to, did we do this already? Yeah. So basically we need to consider IQR, the formula for the IQR. And remember that the outlier, the formula to check for outliers is that if there's a value, so let me just write it down, I guess. So if there's a value that's less than Q1 minus 1.5 times the IQR, then that's an outlier below. So anything below this number is an outlier, and anything above this number is an outlier. Like that. Okay, so what we're going to do is just write a few lines of code to, first of all, get our Q1 and Q3, and then create the IQR, and then we'll check for outliers. Okay, so we want to calculate outliers. All right, so we're going to take Q1. Now, Q1, we can get Q1 by first. I'm just going to do this for anxiety. Yeah, and then leave the final for you to do, because it's the same code. So we're going to take our quantile command, and we want the 25 percentile. So 0.25 will give us Q1. Q3 is the 75th percentile. So I'm going to do the same thing, except I'm going to use 0.75. Okay, that's going to give me Q1 and Q3. Now I need my IQR, which will just be Q3 minus Q1. And we'll put a space here. And then we'll get our lower boundary and our upper boundary. So our lower bound needs to be Q1 minus 1.5 times our IQR. And then we're going to do our upper bound in a similar way. So my upper bound is going to be Q3 plus 1.5 times my IQR. Okay, now to get the outliers, I'm going to basically do like a comparison statement. So I'm going to say identify outliers. And I'm just going to make a little list and then store it in a data frame. All right, so I'm going to call it my outliers. And I'm going to take my data frame. And then here I want anxiety. So I want to take my anxiety. And then I'll say if this is less than the lower bound, and then I need an or statement. So I'm going to use the pipe for or. So, and also let me go ahead and put this in parentheses. Yeah, that's good. Okay. Or if my data frame anxiety, so if any of the values in this column are greater than the upper bound, oops, then we're going to put those into this outliers. Okay, so let me go ahead and run that. Which one's not matching? So I've got this one. No, it's this one, isn't it? I'll leave that. Okay. So now, actually, let me go back over here. Now, the reason this is hard to see maybe is because I've got the screen, like the font set very large. So then what I'm going to do is print these guys. So what did we create, by the way, if you're wondering? We created a data frame like this. Okay. When we wrap that comparison operator, the comparison operation, so what's it doing? It's going through our anxiety column and checking to see if any of the values are less than the lower bounds. And if they are, it's putting them here. It's selecting them basically, and it's going to say, or if any of our column values are greater than the upper bounds, it's going to put them also here in outliers variable. So now let's print that. Actually, I'll just do it like that. Okay, and we can see these are the outliers. All right, so that's great. Now, so this is just the first step in your EDA. Like I said, we haven't done any visualization. It's just an example of some of the different ways you can use Python to ask questions of your data, questions that may be relevant, right? And that'll get you started toward verifying some of those questions with statistical tests, and then enhancing the EDA by using visualizations and so forth. Okay. In our data this time, we didn't have any missing values, so that was okay. But we could also, as part of the cleaning, pre-processing, and even in part of our EDA, we might want to, at that point, determine which variables to remove or which ones to keep, which ones to combine, which ones to aggregate like this. So everything that's done, before starting to create the models, it falls under basically pre-processing and cleaning, and then exploratory data analysis. And you may have heard of feature engineering, and feature engineering basically can happen at any stage, really. It's also sometimes called feature selection, feature engineering. They're kind of similar, they're slightly different, right? But they can happen basically during any time of during the pre-processing, during the cleaning. Let's say you've got a feature that has, too many missing values, you might have to drop it. Or if it's an ID or a name, you might have to drop it. So that's, as you're selecting a feature, then during your exploratory data analysis, you might also decide to drop something. And then after that, after you've built your model, well, during your exploratory data analysis, you might realize that you've got some variables that are highly correlated, and so you have to remove one of them. Or you might see that, one variable can be, let's say you've got like 10 categories, but you could actually make it into 3. Okay. So that just like continues to go on. And then when you build your model, you might realize after you build your model and you look at some of your your beta coefficients for your model or whatever kind of model you have. You're looking at the feature importance. If you have a random tree ensemble, you see that some of your features are not contributing to the model, or if you have a logistic regression, you see that you've got a lot of variables that are not statistically significant, then you can go ahead and drop those. So that's so the feature engineering, feature selection, that's always going on from the start until the finish, until you have a final model that you're ready to start tuning your hyperparameters on, and yeah. So this is just the very beginning EDA. The next step would be to add some visualizations. And then the step after that, after we're adding visualizations, we're doing these basic commands, asking these basic questions. Then our next step would be to do statistical tests to verify our results. Like, is instructor A really, is the average value of instructor A's class really higher than the rest of them? Because just because those numbers are look like that, it sounds strange to say. If we examine it using ANOVA, it may come back, that they're not statistically significant, and we'll have to verify that. So this is just an example, though, and none of it can be, we haven't. We can't say that any of the things we see here are true for anything outside of this set of data. Okay, so it's only this set of data that we're talking about at this point. And if we want to generalize our results, then we'll have to verify some other assumptions about the data before we can do it. All right, so I hope this video is helpful. Thanks for watching. And that's all from me now.